Hello guys, today I'm gonna talk about mesh convergency. Those guys who started doing FEA, for them mesh convergency is very important. So I'm gonna remind you the definition of the node and the element. So node are the joints where we define the degree of freedom. On the other hand, elements. So elements are the blocks that build up the finite element model. So basically, the element it can be consist of several nodes. So for an example, here this is a one-dimensional element where you can see there are only two nodes. Or for two-dimensional element, there can be three nodes, or there can be four nodes. So it will look like a rectangle. One, two, three, four. And if you want to do three-dimensional analysis, in that case your node number can be 6, 8. It depends upon the solution you want to do. So it's very important to remember how many nodes your element have. So let me give you an example how the element plays an important role in FEA. So for an first, so this is a circle, right? And if we take only three elements to define a circle, you see the circle looks like a triangle. So if we increase the number of elements, you'll see that now I have given 8 elements, so it's more close to the circle. If we increase for the number of element, you'll see it will exactly look like a circle. Oops. So now, yeah, I've given around 11 number of elements. So you'll see it's very close to the circle. So the thing is that if you increase the number of elements, the accuracy of your modeling is will increase. It will look like more realistic. So the question comes that why just don't we increase, or why don't we use huge number of element? So the problem is that when you use huge number of element, you increase the simulation time. That means the number of elements is directly proportional to the simulation time. So to solve this problem, finite element engineer they follow a curve. It's called trade-off curve. So the curve it's trade-off between simulation time and number of element and accuracy. In x-axis we'll have number of elements, in y-axis we'll have accuracy. So you can see that after certain number of elements the accuracy is constant. On the other hand, the simulation time is increasing exponentially. So to get the optimized element number, so if we draw a line that has least number of simulation time, higher accuracy, and least number of element, that's the number of elements we want. So we can say that when we have n number of elements, our mesh is converged, or our solution is established. Or so professors say that you have confidence now in your modeling, so go ahead and solve your problem. Thank you guys.